Okay, so this is phase 12, and we're going to talk about rules for definite integrals. So this rule is the order of integration rule, which we're going to use. Yeah, and I guess as I use them, I'll refer to them. Okay, and you could take a look, maybe pause the video and just take a look at them. But again, as we use them, I'll refer to them. So yeah, all right, so let me refer to this additivity rule here. This rule says that if you are, all right, let me show you the rule and then I'll show you how to think it through like conceptually. So the rule, without me talking about concepts, the rule is that if you're adding two definite integrals, as long as the input is the same, okay, so the input function is f of x on both of them, as long as the input is the same and the top of one of the integrals and the bottom of the other integral match, okay, and they could match in other, like this integral could be first, I'll show you later, but if the top of one and the bottom of the other match, the same input in both integrals and a plus sign, so those are the three conditions, plus sign, same input function, top and bottom match, then you could form a single integral, and then this becomes the bottom, and then that becomes the top number. So A to C it would be. All right, and this makes a lot of sense conceptually, which I'll show you in a minute. Okay, or, okay, and A becomes the bottom because that's at the bottom of this integral, and C becomes the top because that's at the top of this integral. So if a number is on the bottom, you can't put it on the top, like in this final one. Okay, or this could have been backwards. It could have been from B to C plus A to B. All right, and then you'd have, this bottom matching that top. So then this is the new top, and that's the new bottom, like that. Okay, so they could match. So the numbers could match going this way also. Okay, guys, so I'm going to do two examples using this rule, and then I'm going to show you how you could think it through just in a really easy way. Okay, so this here, oh, we have a perfect situation. So the input function is h of x, so that's the same. We've got addition between them, and this top number matches that bottom number. So this is the new, that's on the bottom, so that's the new bottom number. That's on the top, so that's the new top number. So we have the integral from 0 to 10 of h of x dx. Okay, now let me do this one, and then I'll show you another way to think it through. So we have the same input function. Okay, so that's something that we need. But we have the tops of both integrals matching. So that doesn't work. But another thing that doesn't work is that this is a minus and not a plus. But we can use the order of integration rule. This says that if you've got an integral from b to a, then that is equal from the negative of the integral from a to b. So you can change the order of the endpoints on the integral, or on the integral if you negate the sign in front. So we could just change that sign because it's like, yeah. So this would be from 0 to 7 h of x dx plus from 7 to 4. Okay, and now you've got this top matching that bottom, so this will be the new bottom, that'll be the new top, and then it'll be from 0 to 4. Okay, now let me draw a line. Okay, because there's another way of thinking of this, and it's kind of nice. Okay, so guys, this means the area under the curve over the interval 0 to 7. This means the area under the curve over the interval 7 to 10. And these intervals are intervals on the x-axis. So if you just do like a number line, and you put like the endpoints on it. So we've got 0, 7, and 10. All right. So, and it's the same function that we're dealing with h of x, the area under the curve. So if you put these intervals together, so this is basically saying, like you can kind of think of it as like, so 0 to 7 plus 7 to 10, and that would be 0 to 10. 0 to 7 plus 7 to 10, and then that would give you this whole thing 0 to 10. Because you're just adding those two intervals together. And so you're integrating over the whole interval 0 to 10. Instead of just over here and then there. You could do the whole thing. Okay, now over here, same idea. Okay, this is going to be the area under the curve from 0 to 7 minus the area under the curve from 4 to 7. So 0, 4, 7. So 0 to 7, so we have the area under the curve of over the whole interval 0 to 7, but then we're subtracting the area under the curve from 4 to 7. So that would leave us just with the area under the curve from 0 to 4. Okay, and it will depend on the situation you're in, guys, whether you want to use, how you want to think it through. But there's two ways of doing it. Okay, now before we move on, all right, well, let me show you this first. So example number 3 is, we've got continuous functions. They've got to tell you that the functions are continuous, because if there's like a gap, if there's like, if I wanted to do, all right, let me just show you an example. If I wanted to do, let's see, this is 0, that's 5. The area under the curve from 0 to 5, and maybe like, so that's like 2, 3, I don't know. And say that the graph is piecewise and it looks like this. Since you can't do area under a graph where it's not defined, okay? So like if this was the graph of f, then we could not take this integral from 0 to 5 because it's not continuous. We've got a gap here. The same thing would go for if it was like, if you had an asymptote. If it's not a continuous curve, then it's not defined, then it's integral. Then you can't find its area. Okay, so you couldn't do the integral. Okay, so yeah. So that's why they're telling you these are continuous functions, and then it's asking you to use these rules here to evaluate these. So give these a try and then see my notes for careful work and answers. Now the practice is on Delta Math, and this is one of the problems from Delta Math. So I'm going to do this, and then you can, just do your own practice. But first I got to show you a couple of things. All right, the definite integral of a constant. So here we have the integral from -2 to 1 of 5. Well, 5, so this means, you ask yourself, what does an integral mean? It means the area under the curve. Okay, 5, so the curve is 5. That's a constant function, guys. So the curve is y equals 5. And we're finding the area underneath it, which means the area between it and the x-axis, on -2 to 1. So we're finding this area. Okay, that's just a rectangle. That is just a rectangle with base 3 and height 5. So the area would be 3 times 5. The area would be 15. So the value of that integral is 15. Yeah, and then over here, so basically, basically whenever you've got a constant function, and you're taking the definite integral of it, you're going to end up with having to find the area of a rectangle. Okay, so that's always going to be base times height. And the height is always going to be the function that's inside there. So you could go super fast and you could just be like, okay, well, I know that this is going to form a rectangle because it's the definite integral of a constant function. So the base would be the length of the interval, just like this. Okay, the base would be the length of the interval, so it would be 12. And then the height would be like the function, so 2. If that was a -2, you'd use -2 for the height. I know it sounds weird to have a negative height, but if it was underneath, if it was -2, it would be below the x-axis, and then you'd have a negative area. 24. Okay, but you could also just do it like this. There's 2, 0, 12. You could just think it through that way. All right, so there's those. Now, order of integration, and then I promise we'll get right to that example. So order of integration, that is this rule up here. Okay, and I just want to show you something. I'm being told that the integral from 9 to 5 is -6. Well, that would mean that the negative of the integral, wait a minute. What does that mean? Yeah. Okay, well then that means that the negative of the integral from 5 to 9 f of x dx equals -6, because these two integrals are the same, guys. Yeah, just this integral here is the same as this one, because I just used the order of integration rule. I put a negative out front and then switched the limits. But then, guys, this is like a -1 here. And if you like isolate that, divide both sides by -1, then you will get the integral from 5 to 9 of f of x equals +6, because you divide both sides by -1. All right, so basically, you can skip this middle step if you ever need to. You could skip this middle step, and if you know the integral from 9 to 5 is -6, then it's got to be true that the integral from 5 to 9 is +6. Okay? Yeah, and then over here, let's try this. So if the integral from 0 to 7 is 3, then it's got to be true that the integral from 7 to 0 is -3. Okay, so just like that. Now let's do this. So f is a continuous function such that this and that. Okay. What is the value of the integral from 0 to 4 of f of x minus 1? So firstly, we can split this up into 0 to 4 f of x minus 0 to 4 of 1. All right, now this one is why I showed you the constant function example earlier. But for this one, yeah, you could even think it through like with, you could think it through like this. So 0 to 4, we want the area under the curve from 0 to 4. We know the area under the curve from 2 to 4 is 3. All right. And we know the area under the curve from 0 to 2 is -1. So from 0 to 2, from 2 to 0, my bad. Okay, we know the area under the curve from 2 to 0 is -1. Well, 2 to 0, guys, is a backwards interval. So I want to be thinking of like it frontwards. So if 2 to 0 is -1, if 2 to 0 has an area of -1, then the integral from 0 to 2 would equal +1, okay, from what I just showed you. And now you have 0 to 2 and 2 to 4. And guys, 0 to 2 and 2 to 4, that makes up this whole interval 0 to 4. So 0 to 2 plus 2 to 4. So we know that the integral from 0 to 2 plus the integral from 2 to 4, that's going to give us the integral from 0 to 4. This is bad notation here because I'm just showing the integral signs. So 0 to 2 is 1. 2 to 4 is 3. Yeah, okay. So, yeah, so this here, actually, let me just use good notation. I'm sorry. Okay, so from 0 to 2, f of x dx plus from 2 to 4. Yeah, because your test is going to be free response, so we should have really good notation. So I just kind of like worked it out over here in my head, and now I'm showing really nice, careful notation. All right, so it's from 0 to 2, the area under the curve is 1, plus from 2 to 4, the area under the curve is 3, minus, so this would give us a rectangle here, guys. So this is y equals 1 from 0 to 4. So the area of this rectangle is 4 times 1, which is 4. So this is 1 plus 3. Oh my gosh, it's 0. Are you kidding me? Okay, I guess so. Alrighty, guys. So yeah, sorry, I was rushing a little bit here. You're gonna want to do a lot of practice, I think. So do this, see my work, and then go to Delta Math. And Delta Math is set so that you can see examples, so that should help you. Please text me if you need anything at all. I'll get right back to you.